All right, good afternoon, everybody. I'm sorry that I could not be there with you today. I scoured the internet looking for a video that would help you get through your homework and could not find one, and so I'm making my own. Let's see, last time we were together, we were talking about tangent lines and secant lines. Okay, and I showed you this document here on Desmos. All right, so that's the graph of x squared. And we're interested in finding equations of tangent lines. Remember, we talked about slopes of tangent lines representing rates of change, anything with that word per in it, like miles per hour, anything with a rate of change. Okay, so we're trying to find the equation of this tangent line here, and this is just an example, the graph of y equals x squared at the point 1, comma 1. Okay, so there's the graph of the tangent line. All right, and the trouble with finding slope we talked about, slope of a tangent line, we only know this one point on the line. We don't know 2 points, and we know from algebra that we need 2 points to find the slope of a line. So we said, why don't we look at secant lines? Okay, and a secant line is going to be one that goes through 2 points on the graph. All right, so let me turn on this point here. All right, so maybe through the point 2 comma 4. And we know that that point is on the graph because this is the graph of x squared. 2 squared is 4. Okay, so let me make this line go through that point. Okay, so now that green line is a secant line. It goes through those 2 points on the graph. Okay, so we're going to go back to algebra for a minute and remember how to find the slope of a line. You've done this before, this is easy, but we just kind of want to warm up this idea. Remember, our equation for slope is y2 minus y1 over x2 minus x1. So we're going to think of this 2 comma 4 point as our second point and 1, 1 as our first point. So we're going to do y2 minus y1 over x2 minus x1. Okay, so the x and y coordinates for the green point here, 2, 4, those are showing up there. Okay, that's y2, x2, and then y1 and x1 are both 1. All right, so let's see, we don't need a calculator for this, right? That's going to be 3 over 1. So the slope of that line is 3. So that's not exactly the slope that I want, okay, but it is a nearby secant line. So our idea is that we're going to take this point up here, this 2 comma 4, and we're going to start sliding it down the red curve, and we're going to get it closer and closer and closer and closer so that the secant line is really, really close to that tangent line that we want. Okay, so I'm going to slide that point, that 2 comma 4 point, a little bit closer. So now this black point here. Okay, and I'm not going to find a specific point right now. I'm going to think about this as just a general point that is somewhere to the right of x equals 1. Okay, so I've just picked this point, and I'm going to think about what would I call this x coordinate down here. Okay, so it's some point that's just a little bit to the right of 1. So we're going to think about this distance from 1 to this new x coordinate here. That little distance we're going to call h. That's just a letter that calculus textbooks tend to use. All right, so this tick mark here, I mean, I have it drawn like at 1.6 something, but let's just pretend it's just an arbitrary spot. We're going to call that x coordinate 1 plus h. Okay, so here's the tick mark 1, and h is going to be this distance between 1 and that new point. Okay, so the x coordinate of this point is 1 plus h. The y coordinate, okay, the y coordinate, this is the graph, the red graph is of y equals x squared. So whatever this point 1 plus h is, whatever that x coordinate is, we would just square it to find the y coordinate. So the y coordinate is 1 plus h squared. All right, so this may seem like a really complicated way to go about finding the slope of this line, but we're trying to find a formula for the slope. So I can find the slopes of all the secant lines that go through the point 1 comma 1. All right, so this arbitrary point here is going to have coordinates 1 plus h, comma 1 plus h squared. And again, the 1 plus h, that's just a point on the x-axis that's a little bit to the right of 1. And the y coordinate is just plugging 1 plus h into the function, which happens to be x squared. Here we're going to do a different function in a few minutes so you get an idea. All right, so we're going to try to find the slope of this green secant line. Okay, so we want the slope y2 minus y1 over x2 minus x1. So just like I did on the last slide, except that my point is no longer that point 2 comma 4, it's this sort of complicated looking thing here. So I'm going to calculate my slope, y2 minus y1 over x2 minus x1. All right, when I do that, I get this messy looking thing. All right, so where did that come from? Okay, so that's my y2. Okay, so that's my second point up there. I just copied my y coordinate, y2 minus y1, okay, which is 1, 1 down there, over x2, my second point there, 1 plus h is the x coordinate, minus x1. Okay. All right, so that is a formula for the slope of the secant line where the second point I'm using isn't just 2 comma 4 or 3 comma 9 or something. It can be any point that I want to. All I have to do is figure out what this distance is between 1 and the point that I want to use for my secant line. All right, now I'm going to simplify this only a little bit. I'm not going to FOIL out this business on top or anything like that. All I'm going to do is take this 1 on the bottom and this -1. Those are going to cancel. It's just going to leave you with, I'm going to leave you with an h down there on the bottom. Okay, but the top is exactly the same. So I've got 1 plus h squared minus 1 over h. And that's the formula for the slope of that green secant line. Okay, so I'm going to recopy that slope formula again on the next slide. I'm running out of room. All right, so I have this slope 1 plus h squared minus 1 over h. And I'm just going to see what that slope value is for different values of h. Okay, so this point, I have it drawn here. Like I said, it looks like it's like 1.6 or something like that. Or maybe a little bit more than 1.6. All right, but let's say that we want to pick h to be 0.1. Okay, so that this point would be at 1.1. Okay, so I'm going to plug in h equals 0.1, just a little bitty distance to the right of 1. So if I just take both of these h's and plug in 0.1 for both of them, all right, I'm going to figure out what the slope of that secant line is. Okay, so grab your calculator and check my math here. So I'm going to plug in 1 plus 0.1, that's 1.1. So 1.1 squared minus 1. So the top gives me 0.21, and then I'm going to divide that by 0.1, and I get 2.1. All right, so the slope of that secant line, if I'm going from x equals 1 to 1.1, the slope is 2.1. All right. All right, so I'm going to keep sliding this point, this black point, closer and closer and closer to this blue point so that I get a secant line that's really, really close to the tangent line that I want. Okay, so let's start again, and let's say that that h is now just 0.001. So obviously the picture doesn't draw it that way. The picture is a little bit further away, but I'm going to take 1 and 0.001 and see what's the secant line between those 2 points. So if I head back over to, let's see. Let's head back over to Desmos. Okay, so this would be like where h is 0.001. Okay. So that would be a secant line. You can't even hardly see that that's a secant line. I don't even think I can zoom in far enough. All right, so I'm at 1.1, and then it's a secant line. It's going through the point right next door over there. Okay, so we're finding it's so close to the tangent line, you can't even tell that it's not the tangent line. Okay, so let's see what that slope is. All right, so we're going to plug in 0.001 for h. So we're picking a really close by neighbor spot. Okay, so on my calculator, I'm going to do 1.001 squared minus 1, and then divide that by 0.001. And I get 2.001. Okay, if you need to, go ahead and pause just to make sure that you are able to type that into your calculator and get the same answer that I am so that you don't get stuck on your homework getting the wrong answer. Okay, so the last time when I picked a point that was, let's see, when we were, I went too far back. Okay, when I was just 0.1 away, we got the slope was 2.1, and now I'm getting 2.001. It kind of looks like maybe the slope of the tangent line is 2. I'm going to check one more point with my secant line. Okay, and the one I'm going to do, I'm going to move that point for the secant line to the left. All right, so here's my point 1, comma 1. And right now I'm just kind of verifying the fact that the slope is 2. I'm already pretty sure that the slope of my tangent line is 2. All right, but I'm picking the point for my secant line to the left. So now I'm not doing 1 plus 0.001 or 1 plus 0.1. I'm actually subtracting. I'm going to the left a little bit. Okay, so my h value is going to be negative. So I may as well pick something really, really close to 1. So I'm going to make that h value be negative 0.001. Okay, so instead of adding 0.001, I'm subtracting 0.001. So I'm letting that h value be negative 0.001. And then negative 0.001 down on the bottom. Okay, so I'm going to plug that into my calculator. 1 minus 0.001, okay, which is 0.999. Square that minus 1, and then divide by negative 0.001. And again, check just to make sure you get the same answer as I am. When I do that, I got 1.999. Okay, and so this makes sense. It's every time I get very, very close, this secant line, every time I pull it really, really close to the point where I want the tangent line, I get something that has a slope very, very close to 2. Okay, so we're going to guess that the slope actually is equal to 2. So here's the graph of y equals x squared and the tangent line that's at 1, 1. And we are guessing that the slope is equal to 2. Okay, so let's remember how to find the equation of a tangent line. We're going to put this to the test. We'll go back to Desmos in a minute. Remember, you may have learned a different way to find the equation of a line, but this is one way to do it. This is the point slope form of a line. Y minus y1 equals m times x minus x1. Okay, the x1 and the y1 come from the point that's on the line, and we know the point is 1, 1. And the m is going to be our slope, which we've just guessed is 2. Okay, so my y1, I'm going to plug in that y equals 1. x1, I'm going to plug in 1. And for m, I'm going to plug in our guess for the slope. Okay, so I plugged in those 3 numbers. Okay, and then I'm just going to make this look like a y equals mx plus b line. I'm going to distribute the 2. Okay, so I'm going to distribute 2x minus 2. All right, and then I'm just going to add this 1 to both sides. So plus 1 will get rid of it over here on the left. Plus 1 will give me minus 1 over on the right. Okay, so this is our best guess for the tangent line there. So I'm going to go back to Desmos. All right. And I'm just going to get myself a blank graph here. So I'm going to graph x squared on Desmos. And then we figured out y equals 2x minus 1. All right. And look, we've got, that's your minus 1 down here. Let me zoom in a little bit. Minus 1 is our y-intercept. Our slope is up 2 to the right 1. And right there it lands at the point 1, 1. And it looks perfectly tangent to that graph right there at 1, 1. Okay, so it looks like we did a good job. Okay. All right, so this is the idea that we're going to get going with next time, with the idea of a limit when we're getting closer and closer to something that we want, but not actually equal to it, because we get something undefined when we're actually equal to it. Okay, so I'm going to do exactly the same thing with a different function and a different point. Okay, so if you feel like you totally understand what I just did and you're ready to try the homework, go give it a shot. And if not, and you're totally lost, then hang with me for a little bit. All right, so I'm going to go to my second example here. All right, so this time I've got the graph of y equals the square root of x, and I'm going to be looking for the tangent line at the point 4, 2. Okay, we're just going to look about like that. Okay, so why is the point 4, 2 on this graph? This is the graph of square root of x. We plotted points for this graph last time or the time before, right? And when I plug in x equals 4, square root of 4 is 2. You can see over here would be 9. Square root of 9 would be 3 on the graph right there, on the red graph. Okay, so that's the graph of the square root of x. And here is the point where I would like that tangent line to be. Okay, and we're going to start looking at secant lines. This one's really hard to see, the secant lines. I got to like go way out before you can see, okay, yeah, that looks like a secant line. Okay. All right, so let's go back over here. We're going to look at, that's a mess. Okay, so there is our graph. Our square root graph is the black curve, and our secant line is the blue curve. Okay, so all our secant lines are going to go through that point 4, 2, and we've got this point over here. Okay, so again, we think about this point, this blue point over here on the right, that secant line point. We're going to slide that along the black curve closer and closer and closer and closer until our secant line is so close to the tangent line that you can barely tell the difference. Okay, but we're going to have it all the way over here so you can actually see that it's a secant line. Okay, so again, we're going to be trying to find that point, okay, in general. Now that point is going to be a small distance. It looks huge right now, but it's going to be a small distance away from 4. Okay, so again, we let the distance from 4 to this point be called h. Okay, so that tick mark on the x-axis is going to be 4 plus h, where h is that small distance. Okay, now this time the y-coordinate is determined by the square root function. The last function was x squared. This function is the square root function. Okay, so I'm going to take, just like I found 4, the y-coordinate was the square root of 4. When the x-coordinate is 4 plus h, the y-coordinate is square root of 4 plus h. Okay, so that's my y-coordinate. Okay, so again, we're going to find the slope of the secant line between these 2 points, 4, 2, and 4 plus h, comma, square root of 4 plus h. Okay, so whatever our x-coordinate is plus h, and then we plug that into whatever function we're doing. I think on your homework you're doing x cubed and the tangent function. All right, so whatever that function is, we're going to plug in for the y-coordinate. And then we find the slope. We're finding the slope between this complicated point and then our point of tangency, 4, 2. Okay, so there's our slope formula again. When you plug in, you're going to get this. So again, where does this stuff come from? Okay, we got our y2, square root of 4 plus h, minus y1. It comes from our first point, our point of tangency. Okay, x2 minus x1. All right, and you're going to start to notice a pattern here. You've got the function business going on up top with the y-coordinates. On the bottom, you're always going to have that number plus h minus the number. The numbers are always going to cancel out and give you this h on the bottom. Okay, so you should have that in both of your homework formulas as well. When I ask you to find the slope of the tangent line, the secant line, you should have that bottom part cancel out so you have just an h. All right. Okay, so we're going to take different values of h, okay, and see what this slope ends up being. And again, the idea is we're sort of mentally dragging this blue point to the left. We're going to get it closer and closer along the curve so that our secant line looks just like our tangent line. Okay, so there's our formula for the slope that we just derived on the last slide. All right, and I'm going to plug in h equals 0.001. We'll kind of skip ahead to the really, really small value. Okay, so grab your calculator and do the square root of 4.001 minus 2, and then divide that by 0.001. Okay, now I get a bunch of decimal places for this one. Square roots are going to do that to you. So I rounded that off at 5 decimal places, 0.24998. The rest of them were 4377, but all right. So if I rounded that off at, 1 decimal place might be a little bit extreme for rounding, but that looks pretty close to 0.25, all right? So I'm going to do the same thing I did last time. So this is a point that's really, really close, probably right in here to the right. Okay, so we've slid that blue point really, really close to 4.001, really, really close. Now we're going to take one that's to the left somewhere. Okay, so now we're not adding a value of h, we're actually subtracting it. So that h value is going to be negative. Okay, so 4 minus 0.001, so I'm putting in a negative value for h. Okay, negative value for h on top, negative value for h on bottom, and we're going to go straight to the calculator. Okay, so do straight to the calculator, square root of 4 minus 0.001 minus 2, big decimal divided by negative 0.001, and I get 0.250015627. Okay. So if I kept that to 5 decimal places, 0.25002. So in the last slide, when I had a point slightly to the right of 4, I got 0.2499. Here I got 2.500. Okay, so 0.25 seems like a reasonable guess. So 0.25 is 1/4. Okay, you can use 0.25, that's fine. I'm going to use 1/4 because, I'm a math teacher, so I like fractions. All right, so I'm guessing that the slope of this tangent line, the line I actually want, is 1/4, because when I took secant lines really, really close by, I got things that were very close to 0.25. All right, so again, let's see if this works. We're going to find the equation of the line that goes through the point 4, 2 that has a slope of 1/4, and then we'll see if it actually works when we graph it on decimals. Okay, so again, there's our point slope form of the line. Y minus y1 equals m times x minus x1. Again, that y1 and the x1 just come from this point, 4, 2. So I'm going to plug in 2 for the y-coordinate and 4 for the x-coordinate. And then my slope, I'm plugging in that 1/4. All right. And then the same deal as what we did last time. I'm going to distribute this 1/4. I'll get 1/4 x. 1/4 times 4 quarter of 4 is 1. Okay, so up here we're going to get y minus 2. I distributed the 1/4, x minus 1. Okay, and then I'm just going to add this 2. Plus 2 will get rid of the 2 on the left. Plus 2 will give me a plus 1 on the right. All right, so that is my best guess for my equation of a tangent line. So I'm going to go back over to Desmos. Okay, I'm going to give myself a blank graph. I'm going to graph the square root of x. And then the line that we found was y equals 1/4 x plus 1. Okay, and then we're just going to go over here. And it sure looks like it's tangent. We can zoom in. All right, and this graph is so, it's got such a gentle slope to it. It's kind of hard to see, but you can see that the point 4, comma 2, that looks exactly like the point of tangent C. So it looks like we got the right line. Okay, so you'll definitely know if you get these right on your homework because you can take the function that I give you and the line that you find and graph them. And if they look like you found the tangent line, then you did it right. So Desmos is a really good resource here. Okay. All right, so let's see. Of course, you are welcome to go to the homework page on Moodle. And the section 2.1 homework, you've just got, these are your Professor Daniel special homework. So this is not problems out of the book. These are 2 functions doing exactly what I just did, finding that slope of a secant line with the h's in it, and then plugging in 0.001, negative 0.001, these tiny values of h, finding the equation of a tangent line, and then graphing it on Desmos to check your answer. All right, so those 2 problems are going to be what is due on Friday, along with what you were going to hand in today. All right, so you'll have a little bit extra due. And we would do more in class if I was with you, but I think probably this is going to be enough for today. Please feel free to email me with any questions that you have, and also to go visit Patricia and/or Bujana at their office hours so that you can get help with it. All right, and I hope to see you all Friday. Have a great day.